Hello, I'm Torstein, and today I would like to talk about declarative sandboxed Python applications and what is the best way to do it in 2022. And this, at least, is the best thing I have come up with. So I'll explain what I want. I want a declaratable configuration of it, something that's machine readable, something that can be parsed and automatically updated and so on with other tools. I want sandboxing. Docker is really nice, but I want this sandboxed wherever it is. And I want to organize my app using Python modules. So this application might start out as small as Python applications often start out, but I want this to be able to grow into the future and still be maintainable. So I want modules, not everything in the same directory. I want a Unix command to start off my app. And I want repeatable builds. It should work on my computer, on Jenkins, in OpenShift, and whatever consultants trying to run something in Docker Compose for a client. It should work everywhere, right? So let's do it. So there is this declarative build configuration introduced in Pip.5.17, which put forth a couple of things. One of which is a setup.cfg file. So let's have a look what that looks like, because you're probably used to setup.py, and this is rather new. So obviously metadata, and then options, and here is the most interesting bit as far as I'm concerned. There's a directive called find namespace, and this makes it possible to have a source directory, and inside the source directory you can have your package structure. So for me that's netskybert 1 and your Python files, under that tray, and it will just figure it all out for you. So this here is a brilliant line. Find namespace, that takes the option find, which is a bit confusing, but it's just the way it is. And here it says where to find it, so that's in source. All right, and then this is the dependency list. So my application right now has one dependency, which is the brilliant requests library. So let's try to build that. So I have a directory here, and as you can see, there are no files here. So we're building it together from the ground up. All right. So setup.cfg, and let me switch to the presentation, and I can copy that and paste it in there. Okay, so let's see if that works. So what I want to be able to do, so here I have license setup.cfg, that's all, and I want to be able to do pipenv install, and then I want to do run in my application. This is basically what I want to achieve, and then I also want it to be ensure that it's repeatable and so on, but this is basically what I want. So let's try that out, and it goes just this far, not further. So we need a couple of more things. So let's see where to so yes, so the pip file, we didn't write the pip file, right? But if we examine the directory, you can see that we've gotten a pip file generated. So pip and install created one for us, and also create a log file, which is the resolved dependency graph for that. So you depend on only one dependency, but that dependency again has other dependencies, and all of that is then resolved and then put into the log file, like you probably already know, but just mentioning it. Right, well anyway, pip file, we didn't write one, but they create one for us, and in order for this setup.cfg to be wired up here and still being able to use pipenv, we need a tiny little bit of help. We need this line here. So instead of packages, we need to say package, kind of declare how our package is being built, and the path is then current directory. Now, so this is pip file, and then that should then reach out to setup.cfg. Let's see if that works. So I switch to my shell and I run install again, and it cannot figure it out. It says failed parsing requirement from dot. So it didn't manage to go from that dot here to CFG. It cannot make that leap, if you will. So let's make that a bit bigger. So we still need the good old setup.py. Right, and we don't need that much, but we do need these 2 lines. I can make that a bit smaller. Put that in there, right? Not a lot to it, but this here ensures that it manages to get the link and make everything work for us. So now it has resolved the dependencies. Now it's trying to lock the dependency graph and then install the dependencies and then hopefully run our application. Let's see how that goes. So that it still has a problem, and the problem is naturally that we haven't created any application. So in setup.cfg we can just cat the file and we can say, well, it needs to live in source. Let's see, what did I want to say? Yeah, oh yeah, we haven't even defined it, hang on. Let's, yeah, so we need, okay, we can do that. We can create the path and we can just touch the init.py there, but we still need to, let's see, where did I put the notes on that one? Yeah, we want an entry point. So this is to get the Unix command to work. We need kind of to define what should happen when you type 1 inside of the right environment, given that Python is set up correctly and the path is correct. So we need to add this here to setup.cfg, like that. Now this says create a script, create a command line called 1, and that should call out to netskyber 1, which we just created the init py for, and then the main.py file, and then the run function. This of course must be created or else it will not work. So netskyber and then 1, and we have the init py, that's fine. Then we need main py. Then the shebang. Since this runs inside of a virtual environment now, we should do it this way. So we don't hard code it to user bin Python, because then the sandboxing won't help us. We need this. So this calls out then to give me the Python 3, whatever it is, first in path. And the virtual environment mechanism ensures that the correct Python 3 is first in path. Right, and then we need some code. Let's say write some code. Here we go. There. All right. So let's try to run all of this and see if we're home free. So what we did now, we created the main function, which should be executed, right? But the way this works is that we configure which function should be called. It's not given its main. So it's not like calling the function, it's not like calling the Python program directly that you would normally do. So let's fix that, and that's easy enough. It's just to remove that and just do def run instead, like that. So what the code does is uses requests to pull down python.org and then read the HTTP response headers and print that to the console, so we can just see it's working. All right, let's run it again. Excellent, it works. Right, so we've now build everything and run it inside the environment, and we now have a Unix command that we can run. We can even do pipe, start a shell inside, and then we have the one command that we can run. All right, very good. So then we have one last thing. We want to make it repeatable. So if you see here in the CFG file, we just say that we require requests, but we don't say which version. So if we build this tomorrow, so we built this today, right? And today the last stable release, current stable release is 2.27.1, but tomorrow it could be 2.28, and the dependency graph will then change. And when running this code on other computers for customers, clients, you definitely want a repeatable build and definitely want to have full control over the dependencies. So put this in here, and now and then generate a new Pipfile.lock file, and now it's repeatable. Now it will always produce the same dependency graph on all computers. Can of course verify that this still works, but it will. There we go. I think that's it. Right, so summarize. So now we have a declarative build configuration with setup.cfg. We have sandboxing with Pipfile and pipenv that we've had for many years. That still works the same way as it used to. We can organize our Python application in modules. We have a Unix command that we can call our app, and we can create several Unix commands. And it's repeatable. It will build the same on all computers. So with that, I thank you so much for listening in, and I will see you next time.